Kindly keep your microphones muted during the session. Please use the chat box for your questions. We will collect them and present them to the speaker at the right time. Keep your questions brief and to the point so that more participants can be accommodated. We request everyone to stay engaged throughout the plenary, as this will be interactive and highly informative. Thank you for your cooperation. Just to outline today's flow, the session will be conducted in two parts. Dr. Mishra will speak for 35 minutes, followed by a 5-minute Q&A. After that, we will resume for another 35 minutes and conclude with a final 7-minute Q&A. On behalf of Kerala Public Schools, it is my privilege to welcome each one of you to this feature session. A very warm welcome to the dignitaries, respected teachers, and brilliant students joining us from schools across different cities. We are honored to welcome Dr. Sulagna Mishra, Scientific Officer in the Hydrology, Water, and Cryosphere Division at the World Meteorological Organization. We are especially grateful to Dr. Mishra for joining us from Geneva at such an early hour. Despite her extremely packed schedule, she has graciously accommodated our request to be with us today. Thank you, ma'am. At WMO, Dr. Mishra oversees the development and implementation of the Global Hydrological Status and Outlook System, leads the publication of the State of Global Water Resources Report, and coordinates the services component of cryosphere-related activities, including the International Year of Glaciers Preservation. Dr. Mishra is an environmental scientist with extensive expertise in hydrology, water quality modeling, and water resources management. She holds her bachelor's degree in civil engineering from BIT Mesra, India, a master's in hydrology and environmental management from TU Darmstadt, Germany, and a doctorate from TU Dresden, Germany, where her research supported water quality planning in challenging environments. With global experience spanning Europe, the USA, and India in international organizations, academia, and the private sector, Dr. Mishra brings a wealth of knowledge and perspective. We are delighted to have her with us today to share her insights. Let us warmly welcome Dr. Sulagna Mishra. Welcome, ma'am. Dr. Mishra, the session is now yours.
Thank you, Sangeeta. Thank you all of you for being in this talk and inviting me to hear us what we do at WMO and also our perspective on how to connect the global and to the local, and for the great work that the Kerala schools and the students are doing when it comes to climate action. Sangeeta, if you may allow, I will change the flow of the session slightly. Instead of giving 35 minutes presentations in 2 slots, I'll make it 20 so that the students have more time for questions. Yeah, I have extra slides in case there are less questions. I can take it on, but it's better to give students the chance to speak. So the title of my presentation is Climate Actions, Connecting Global to Local. I will also like to hear during the talk what the students of the Kerala schools are doing, also to get a bit more insight into the local actions. And yeah, whenever, as Sangeeta just said, whenever you have questions, please type them in as they come, and we will take them when the time comes. We'll have 2 breaks and we'll take the questions then. Sangeeta already introduced me very well, so thank you so much. That was very generous. A very short couple of insights to that as well. This is mainly for the students. My master's program that I did in Germany, this was through a fellowship program called the DAAD. It's funded by the German government. My engineering was very close to Jamshedpur. It was in BIT Mesra in Jharkhand, and I have also worked for a couple of years in a company called Simplex Infrastructure in Kolkata. This was right after my bachelor's in civil engineering, and I also did an internship, which is also something that students look into a lot, which is usually very helpful to give them a perspective into what they want to do next in their careers. And I've done a couple of internships at every stage of my career. So during my bachelor's, I did a few internships in companies and also in academia. Back then, it was in IIT Kanpur and in an engineering company called Gammon. During my master's, I did an internship with the UN. This was again funded through a Carlo Schmidt fellowship, which is a government fellowship of Germany. And during my PhD as well, I did an internship partly, which divides my PhD partly in Germany and partly in the US. So this is from my experience that internships helps a lot in giving us a perspective and helping us understand with a first-hand experience of what we like to do and where our interests are and where we can actually excel. So I would really encourage students to, in whichever career stage they are, to take up internships, shorter or longer, doesn't really matter, but 3 to 6 months or 1 year of internships to understand where their passion is. Since 2021, so before this, I was in academia. I was doing my PhD and a postdoc. And since 2021, I am with the WMO and really enjoying my role here. As Sangeeta mentioned, I coordinate the Hydro SOS, Hydrological Status and Outlook System. I will show a little bit what that does. And we also do the State of the Global Water Resources report. And currently, we have the International Year of Glacier Preservation, which is a political year to raise awareness on the preservation of glaciers and how we can really not really preserve, but also at the same time adapt to when we are not able to preserve, because in many cases we are really not able to preserve anymore because they have crossed the tipping point. So with that, let's go in. Why do we really need operational hydrology? Why do we need to preserve our glaciers? The hydrological cycles, as we know, the water cycle, in more technical terms, we call it the hydrological cycle. This is getting more and more erratic. So we are getting more floods, more droughts, more glaciers are melting. And because of all of this, we need to monitor them. We need to predict what is coming next. And for this, we need the skills, we need the data, and these are not problems that are contained by the national boundaries. And this is where we need the global or the regional picture as well. But of course, it starts from our house. We need to see what is happening at our basin, at our locality, and then it pans on to go to the bigger scale. And why all of this is happening is, of course, gets triggered. Sorry, Sangeeta, can you please confirm that you're able to see my screen?
Yes, absolutely. We are
Okay,
able to see.
perfect. Okay, thank you. And why all of this is happening is because, of course, it starts with the current changes in the climate. This is the temperature trends that you see. We used to be much bluer meaning colder, and now, as you see, we are getting more and more hotter. The 2023, for example, since the last 5-6 years, we have seen the hottest temperatures ever. So every year we are breaking our own records, and 2024 was just declared as the hottest year ever in record. And we are just making these statements every year. We made this statement in 2023 as well, and the same in 2024. And it says how our choices are going to affect the temperature in the coming years. And it says if we delay action, then we are going to see a 3-degree raise in the temperature. Now we have already reached the 1.5, and if our choices don't change, we are going to see this getting even darker, redder. So it means it's going to get much above normal, which we are already starting to see, but it could get devastating. And even with rapid action, it's not that it's going to get better. Even with rapid action, the column in the little panel on the bottom, it shows even with the rapid action, we are not going to get any bluer. It's just going to get less redder. And therefore, even if we are doing a lot of changing to the changing of the fossil fuels, for example, or making greener choices, even then we will need climate action, and we will need mitigation and adaptation actions. we know that almost half of the globe at the moment, they live in areas that suffer from at least 1 month of water scarcity. This is an older report from the World Water Development Report from 2018, but this has only changed for the worse. We didn't have this study repeated in recent times, but we only know that this has changed for the worse and hasn't gotten any better. This is the drought risk. When it comes to flood, we know that almost 2 billion people are exposed directly to 100 years floods, and we are seeing what is happening in South Asia at the moment. For example, we are seeing floods that come back in 1 in 5 years, in 1 in 40 years, 1 in 50 years. So the situation is only getting worse and worse. At the same time, because it's the year of glacier preservation, we have some numbers from glaciers as well. They are melting at the rate we have never seen them melt before. In the last 40 years, we have in the last from 2006 from 1960s until now, or last 50, 60 years, sorry, from in the last 50, 60 years, since when we have the data, the monitoring has been done regularly. We know that whatever has been lost, 40% is only lost in the last decade. So of the entire loss in the last 60 years, only the last 10 years, 40% has gone. So this is exponentially increasing, and we have seen that in all the glaciated areas. We have 19 overall glaciated areas, Hindu Kush Himalayas, for example, being considered one, Alps being considered one. So all glaciers around the world, we have around 200,000 glaciers globally, and all of them are clustered into 19 groups, and all of them have lost mass consecutively in the last 3 years. Sometimes it happens that one area is losing while the other area is gaining, because there are micro differences in the temperatures here and there. However, in the last years, all of them are losing. When you look at a map of high impact events, this is high impact events of 2024. When you look at that map, you can really see how many flooding events have happened globally. And here we, of course, don't mention all. If we mention all, this entire map will be filled with dots. What we show here are the events that really cross the threshold. Either they were 1 in 100 years floods, or they had a number of unprecedented number of amount of losses in terms of economical losses, or number of people that passed away or were affected, not just deaths, but also displacement of people. And the highlight events, let's put it like that, the highlight events make it into this chart here. And even though I say it was a very, very hot year, it was the hottest year on record, you can see how many blue dots are there. Blue dots meaning floods. So if it was the hottest year, why so many floods? We should have rather seen a lot more droughts, isn't it? But this is really because of the erratic behavior. So when there is when the temperature is very, very hot, you have more evaporation. This is creating much more clouds, much more vapor in the atmosphere. This then holds even more heat in the atmosphere, generating even more temperature rise, and then these are all moving in directions that we are not able to predict already now. And then there are cloud bursts because of this high heating temperature. Oceans are heating up, so they are also creating a lot of typhoons, cyclones. We see this every year in India, almost every year we see it in US now, and we see small island countries are affected a lot because of coastal inundation, and this is triggered by the heat, of course, but we see this impact really everywhere around the globe. For example, glaciers melting, we see so many gulfs, the glacier lake outburst floods. We see this in India, Nepal every year, and also in other areas. But why is this happening? It's mainly because of temperature rise, and then if it's not predicted well, you're not able to displace people. Of course, this cannot be stopped. The gloves cannot be stopped. What we could do is displace the people in the right time. So villages are wiped off, but not people. However, because of no incorrect prediction, or because of our limited ability to predict it in the right time and take right action, we do get a lot of damages in terms of economy and in terms of people as well. Now, why are we not able to predict this? Are ministers or the policymakers, the presidents, the prime minister, are they not aware of this? To understand this, our friends from the Water Policy Group in 2023, they did a survey. They asked heads of states, environmental ministers, water ministers of 92 countries about what they think are the highest risk in maintaining and achieving good water management in their countries. This was only asked to the highest level heads of state, and the survey says here that it is absolutely understood by the policymakers that the main problem, or the main driver of all these problems, are climate change. This was ranked as the highest one, picked out by the people who were interviewed. The second was increasing demand of water. We all know this because of population increase, more people moving towards urban, and this is a pattern that we see in most of the developing countries as well. Increased demand, or unbalanced demand of water. This is also a big problem which the politicians are trying to, or the policymakers are working on. And the next ones are droughts and floods. So we all know that we all know that this is the big problem in hand. And it's not that just at we know this in when we are sitting in our governments, but when they meet at the global conferences as well, this is a hot topic, because of which after 46 years, we had the first intergovernmental attempt, which was called the UN Water Conference. This the first one was way back, 46 years back in Brazil, and this in 2023 we had the next water conference, which happened in New York. And in this conference, we had more than 2,500 participants, including 11 heads of states, 120 ministers from different countries, and 166 member states delivered their statements on how they're going to adapt and mitigate the effects of climate change, especially keeping water in mind. And why water? Because most of the effect of climate change is felt through water. Even if it's a drought or a flood, you feel it through water. Either it's too much or too little, or too dirty, or you're not able to use it, and so on. So when we talk about climate change, the impact of climate change is seen through water. This is why we try to mitigate it through the water lens. And now the problem is identified as so big that we are going to have UN Water Conference, bringing all the countries together every 3 years. So the next UN Water Conference is going to happen in 2026. So these two slides were just to highlight that even at the highest level, it's not just at the government or the state level, the country or the state level, even at the highest levels, as in bringing all the partners or the stakeholders together, we are also trying to address this issue. So this is going from global to local. At the global state as well, we are discussing this. And of course, at the local stage, we have to create the capacities. We have to monitor better and predict the situation better. Keeping this in mind, we also had in 2023 UN Secretary General Antonio Guterres, he made a call for early warning for all. The idea was by 2027, everyone in every country, every citizen of the globe should have access to early warning for all. What is early warning? Whenever a disaster is able to come, we should have enough lead time to know about this. We are able to predict it in the right time. We know that the flood is coming, a drought is coming, a cyclone is coming. whatever is coming, we know that, we know how to react. We everyone, when I say it not just means the state government, but every single person on earth, they should be aware that it's coming, how they should react. They should have the facility to move to a different place. They should have, if needed, they should have the relief that they need, a few days of food, clothes, etc. So everyone should be absolutely prepared for every single event that is happening. This was a call that was made, and the target was 2027. We did a survey last year in understanding how many countries are actually there, how many countries actually have operational early warning system. Even when you take India, we have there are certain kind of events for which we are always well prepared, thanks to our IMD, Indian Meteorological Department, our CWC, the Central Water Commission. We are prepared for many of the events, but not all. We get a few days of notice. For example, now for every cyclone, we have a few days of notice. We are very, very well prepared for cyclone. India, for example, is also the hub that sends and helps countries in the entire region for making cyclone warning. We even also help US to make cyclone warning. So India has mastered one of the skills, which is cyclone prediction. But when it comes to others, there is still room for improvement. However, of course, we are doing very well in many of the prediction, but this is a case of India. When it comes to flash flood guidance system, for example, flash floods happens within minutes. The reaction time is 15 minutes. However, through systems like flash flood guidance system, the one that happened in Uttarakhand a few days ago, India was able to give a prediction 1 day in advance. So when the prediction comes this much in advance, then people have enough time to react, to move, and to prepare themselves and their families and their businesses, and at least save themselves and the basics that they need to. But these kind of skills need to be disseminated everywhere, and there is, of course, room for improvement everywhere. When it comes to GLOFs, the glacier lake outburst, there are many times we have had smaller GLOFs here and there in Shimla, in other places that we have seen in news that we were probably not able to predict with enough lead time. So people were not able to react. Sometimes tourists were washed away. And it's not just about the floods. There is always also often landslides and other things that then affects the entire area and then closes the entire area, etc. So this is early warning for all. And the idea is we should have early warning for all kinds of disasters, for all times, for all people. Now, this is one of the last slides of this section of my talk. I like to spend a couple of minutes here. So when it comes to early warning for all, it has 4 major components. One, of course, the one that WMO is responsible for is to make sure that we have all the right kind of data that is needed for making the predictions. WMO helps the member states to make sure that they have the capacity, that they're able to use this data to make the right predictions, also standardized predictions, standardized exchange of data, because if you don't exchange data among each other, we cannot make the right predictions because the basins span across borders, and also to make sure that they're using innovative technologies as in remote sensing wherever it is required and other technologies, so that and also now we are talking about AI, machine learning a lot, how to make sure that these are also used to make our predictions better. So this is the WMO part. Then we have ITU, the telecom unit, which also is a part of the UN. What ITU is responsible for is once the data is there, once the information is there, how to make sure that these are used properly and communicated properly. So it works very closely with the telecom units of the government, and makes sure to apply the standard operational procedure. We have the Red Cross. The international body of Red Cross is called IFRC, International Federation of Red Cross, and they make sure that the communities are prepared. So it goes a bit deeper into the level, and it makes sure the communities are prepared, anticipated actions are taken. You have the risk maps, the advisories are generated, and youth, older people, women, they are all aware of what is happening, and they know how to react. That's IFRC, the Red Cross, and then we have the UNDRR, which collects all this data, which overlooks the procedure of risk data that is generated, and it makes sure that the forecasting is being issued and the warnings are being issued. This is the UNDRR, UN Disaster Risk Reduction. So the risk of the disaster is already reduced. But when the disaster comes, then the other parties, they take a wider role. So in all of these, you can see that local people, youth, women, the marginalized, they also have a very strong role to play. One, when it comes to awareness, when the warning is coming, what do we do with that? Also, how do we help in generating the warning? So if because there's often the case that you have, let's say, smaller settlements, bastis that we call in India, they are there closer to your areas, but they don't probably have the access or the knowledge to understand these kind of things. So this is one area where we always say youth or students can play a very significant role in explaining to them how they can really react and tackle these kind of issues. Now, this is, we did a cost benefit analysis of how investments can, because for all of this, we need more investments, right? To have good forecasting systems, or to make people react, or to have early warning system, we need good investments. Financials are always often the bottleneck. The resources are often the bottleneck. And to make the point clear that one life saved or one drought well predicted is actually a lot more cost, or saves us a lot more money. We did an investment of what early warning system actually brings in. Should banks, should governments, should our budget have a big space for early warning system? And what it showed was making water resources more resilient, building dams, building mangroves, dryland agriculture, crop production. All of this have a good net benefit. However, when it comes to benefit cost ratio, how much do we invest and how much we get back, this is extremely high when it comes to early warning system. When we are able to predict a flood or a drought or a typhoon, when you are able to predict it at the right time, and you are able to save the people or save the businesses, then we are actually earning a lot more. It's 1:10. This is one of the highest cost benefit ratio. When you spend $1, you're actually saving $10. This is huge. So it makes a case for why we should really invest, or why the government should really invest more when it comes to early warning systems. Now, I spoke about that WMO works on a certain specific fields when it comes to early warning for all, but I would like to give a little bit of background of what is WMO actually. You're all aware of UN. What UN does, it brings together all the member states. We have 196 member states when it comes to the UN, and the global decisions, the regional decision, when it goes span the country boundaries, these are often taken either bilaterally if it's one or two countries, but when it's more, we do it at a regional scale, or we do it at a global scale at the UN. For the regional scale, we have regional bodies, or we have sub bodies of the UN as well. So the global UN is also divided into regional offices. So we also help in bilaterals there. However, when it comes to the global decision making, what should be the standards for a certain thing globally? So these kind of decisions are taken then in the UN. We have the Security Council. This is very popular. This is something that you see in news every day. Now, in the current situation with wars, you hear about the UN Security Council very often, but UN also has several other specific or specialized body. WHO is something we hear very often. Global. This is the World Health Organization. When the COVID hit us, we were always looking for what is the WHO saying, because these are standards that are then set for the global audience, and the decisions are taken together by all the countries. And WMO, World Meteorological Organization, is the specialized agency of the UN, which looks into weather, water, and climate. So anything that is related, any topic that is related to weather, water, and climate, this is taken by WMO. It was set up originally in 1950s before the UN was set up. This was called the International Meteorological Organization. This is a successor. And in 1973, after the UN was set up, it was moved into the UN system, calling itself the World Meteorological Organization. We just finished 100. Of the total, we have 150 years, but roughly for WMO, we are just celebrating the 75th year. So what's the purpose? What do? We facilitate worldwide cooperation when it comes to the fields of meteorology, climate, temperature, hydrology, and also how we apply it for the benefit of all. So we collect the state of the art knowledge. We make sure the calculations are done in a standardized way. We exchange information and data in all the three fields: meteorology, climatology, and hydrology. We promote standardization of the observations, because if two different countries are calculating or collecting some information and sending both of them to us, but not in a standardized way, we are basically comparing apples and oranges. So this is something that we are making sure that if we are not getting 193 apples and oranges, but we are really getting one standardized the calculations or the collections of the data, the storing of the data, the exchange of the data is all done in a very, very standardized way. This then makes it easy for everyone, or it even makes it possible for everyone to use these kind of information for their national models, or also for the global models when we are talking about predictions, or also when we are talking about looking back and trying to understand what really happened, why did this flood actually happen, so to attribute why we see these kind of damages and these kind of patterns in our atmosphere or in our land. Then we have operational hydrology is also used for water management, for agriculture, policy making. So if the data comes in and it sits in Excel tables, it's not really useful. So what we do also is support the member states to convert these Excel tables information, gigabytes and gigabytes of information in Excel tables, to real information saying, meaning a standardized map or a standardized graph, or what can you really make out of this information. I'll show you some examples when we go further. And we also do a lot of capacity building. We have a research and training unit which brings together or makes the different scientific groups around the world work together towards solving global issues. We collect issues and wish lists from the governments, and then we bring it to the regional and the global forums, and we make sure that the scientists are working on it. So not just local to global, we are also downscaling global to local. So whatever available information is there at the global scale, we also try to make this available in easier, easy to digest format at the local stage, and making it adaptable to the local stage. And with this, I will stop and I'll pause for questions. I'm sure this was a lot of information, but feel free to ask questions, and then we take it from there.
Yes, are there any questions?
Sangeeta, you might also allow them to speak up, maybe?
Yes. Mr. Saikat, you can unmute them. There is a question here. It's from Richa to everyone. In my school, we have shown videos on conservation and preservation of water. What else can we do?
Thank you, Richa. Sure, conservation and preservation you're doing this at a personal level, but if you think a little bit out of the box, you can also, this is of course water, but then the next practices are with plastic, with not just conservation and preservation of water, but also have you changed the cars? Have you changed to e-cars? Do you use your bike more often? Bike as in the cycle more often for 1 kilometer? I have seen this practice also in my house. If I ask my dad to just take the bike, he'll be, no, I will just take the car, even if it's for 1 kilometer. So these are practices that we should be changing. These are lifestyle changes that we should be bringing in. Often our practice stops with water, but it really should go with every aspect of our life. Preserving electricity, because most of our electricity sources are also not hydel. Many part of it is also coming from coal and other fossil fuels. So changing or preserving electricity as much as we can, not running our ACs at 20 degrees, but more at 22, 23, which will also stop a little bit, or it will stop if everybody around you does it. This will also help us in the global heating that we see. The greenhouse gases are also in all-time high. So it's not just water, but if you look at the individual level, you can have a cascading effect really at every aspect of your lifestyle. If you ask yourself, if with almost all your activities, if you ask yourself, can I do this a little bit better, or can I do this a little bit more cautiously for the society, you will have some answers for all of this. Thank you.
We have another question over here from Ms. Polami Sarkar. Managing wastewater in schools is becoming more and more difficult. What activities do you suggest to manage it in schools?
If you can give me a little bit of insight of what is already being done in the schools, I would like to hear that. But I can already answer this. Often, we have 3 degrees of screening when it comes to wastewater treatment. We have the first screening for the bigger plastics and the bigger bodies. Then we have a biological screening, and then the last one we do is ozone or a reverse osmosis or something like this. The last step. The last step is often optional. However, the first two steps are done. The first one and the second one with flocculation and some kind of settlement, and these are often done. What we often encourage to do in many of the cases, in one of the projects that I was in, we did manage aquifer recharge. So what we did was basically, instead of throwing this water back to a water body, we used the sand pits. So we used the land surface. So we had designated areas of land where we dumped this water, and the land basically used or the land acted as a filter, as a sand filter. And what we saw, we did it in form of an experiment. What we saw was, because of this water going down, the cleaned or the treated water going down through the land filter, when it entered the aquifer, this was already quite pure, and it had good properties, and it actually helped in recharging the aquifer instead of throwing it back to the river. So this was one of the things that we do. But I would like to hear from you what you do in your school as well.
Yes, Polami, you can unmute yourself and you can answer.
I think she has typed. So she says rainwater harvesting is going on. Rainwater harvesting doesn't count as wastewater treatment, actually. It should be directly harvested into the groundwater or to the closest water body, usually to the groundwater. But wastewater that is coming from the kitchens and the basins are just being wasted. So this is something that can be improved. What you could do is have basic filtration and then do the same that you do with the rainwater harvesting. The same techniques can be used for wastewater as well.
So just now when you spoke about aquifers and making those sand pits, and then the water seeps into that, and from there it goes to, so do we have to identify aquifers before we make the sand pits?
No, they will find itself.
Yeah. Okay. So we can do it anywhere. Basically, this is for wastewater. The suggestion is for wastewater, right?
Yeah, and also for rainwater. Any excess of water can be actually used for. This is called managed aquifer recharge. So you're basically recharging your groundwater. In Israel, for example, they use because it's land. They have a large coastline, and it doesn't have enough water. What they do is use desalinated water. So for them, pumping out water from the aquifer is more expensive than desalinating water. So they use a lot of desalinating water. And earlier, what they used to do was throw away so they used to desalinate excess water. They did reverse osmosis. They get the best quality water, of course. They spend a lot of money, and then they used to throw back the water into the sea. This was years ago. And then they found this technique of managed aquifer recharge, which is cheap, natural. You just have to throw the water into big pits and it seeps in by itself. And now their groundwater table has also gone up, and they are also not wasting water anymore. So managed aquifer recharge is actually a technique that many of the countries have started using now.
That's a wonderful idea. I think now we can, if we could get more information from you, even after the session, like if there's a way for the schools to reach out to you, of course, I'll be the person getting the information from the schools to you, so that they can get information to carry on with the work and to progress in whatever intentions they have with this program.
Absolutely.
Yeah. Any more questions, please?
I'd like to ask a question over here. What is the maintenance aspect of the sand recharge pit? Means if we
It has to be, it depends a little bit on the content of the water as well. If it is well filtered before it is being thrown in, then you will not get a lot of biological growth on the sand, because the biological growth, they will stay on the surface. If it's already well filtered for the biological content, so we often advise this after the flocculation coagulation step, and after the cleanest form of water that you can already have from wastewater is then thrown into the pit. Same like rainwater. For rainwater, you don't need a lot of cleaning. It's already, if it's not washing a lot of surfaces, but it's only coming from the roof, it's already quite clean. This is then directly put into the groundwater. Similarly, the wastewater that is coming out of the basins and washrooms, and the kitchen, for example, if this can be cleaned of the biological waste as much as you can, and then we put it into the sand pits, what we often have seen is we need scraping of the sand once every few months when you see growth on the sand, because they will filter out the left out stuff. So a little bit of scraping of that and changing of the sand every few months or so. It really depends on what is the content of the water.
Is there any special disposal protocol attached with the sand that we have scraped off now?
We have to check that. We don't do this operationally. This is from one of the projects of the past that I did. We can check this out. I'm sure there will be.
Sangeeta,
This is not the core
Pallavi ma'am
business
is
of
asking. Sorry.
water quality is not the core business of WMO. It comes under UNEP, United Nations Environment Program. They are the ones. They are the custodians of water quality.
Thank you, ma'am. Sangeeta ma'am, Pallavi Sarkar ma'am over here is asking, can questions be asked?
Please unmute yourself. Call me. Ask. Anybody, the audience, feel free to ask questions quickly. Unmute yourselves. A minute more and then we will move on. Yes. Vijay ma'am has asked a question. What about atmospheric water generator? Is it advisable to install it?
This, I will actually refrain from answering this, because this is not our core business. And this is something that no, I'm not very comfortable with answering this. I will not like to say something about this. This is not my. There's an echo, sorry.
Yes, just a minute. Paulami, just mute yourself, please. Just for a minute. Ma'am is answering the question. Yes, please.
I know there is a lot of discussion around atmospheric water generator, about cloud bursting. Can we do artificial rains? Can we cover the what is it, the glaciers with geotextiles to save them? These are all artificial methods, and until we have enough evidence that this has no impact on the environment, otherwise these are all new methods, and unless we have enough evidence that this has in fact no impact on our neighbors or on our other countries, we don't like to advise or provide any kind of guidelines on this. So I will refrain from answering this question, sorry, about the atmospheric generator. We don't have enough evidence to say whether it's advisable or not. It's still at experimental stage, and we can't say yet if it's advisable.
Thank you. Any more questions? Yes, Paulomi, you can now ask, please, quickly. Anybody else? Be ready
Can
to ask.
small actions, so Paulomi asks, can small eco actions in school really balance out the damage done by big industries? Yes, of course. At every we hear this very often. Every drop counts, isn't it? So every little action that you do is going to have a cascading impact, not just in your school. When one school sees the other one doing it, so they will probably start doing this as well. And when 50 schools do it, probably they cancel out one small industry in the area. And when 50 small industries do it, they will cancel out one large industry. So this is how climate action or any positive reaction that starts in the society changes. If I will give you the story of um, the prediction systems, for example, that started. Um, when we had the first super cyclone in Odisha, the second one. The first one was in early 19 what was it, 1972 or something like this. But the biggest one that I have seen when I was small was 1999, which was called the super cyclone. And the government started setting up the prediction systems and the relief houses and all of this after this one big cyclone. But then by the time the second cyclone came, we had almost in Philin, for example, or Fani, we had zero casualties. We had zero, the people were displaced, of course, but because of the cyclone, there was zero casualty. Whereas in case of the first cyclone, villages were wiped off. So it starts with small actions, and it starts with taking the first right step. So we can't wait for everything to change and then we start changing stuff, but we start with a small change and then we will see all the impact.
Any more questions?
I have one last question I'd like to ask over here. The WMO collects enormous amounts of climate and hydrological data. How can students or young researchers access and actually use this global data set at a community level or school level project?
Very, very good question, Saikar. We actually don't collect data and store it. So we make data collection possible. So we accommodate data collection when we make sure that we have the centers. So we have the secretariat in Geneva. In the secretariat, we have no data. We have centers, global and regional centers that are hosted by the member states, and they collect the data. We facilitate the collection of the data. So we don't store the data here, but we only facilitate the collection of the data and we make the data available to everyone. So if you're affiliated or if you are, so most of the data, the idea is to have open data sharing. So we advocate for open data sharing. We have the open data policy. So every data is for the global good and should be shared is the policy. Of course, not all countries want to share all the data. Some of the data is also treated as national secrets when it comes to hydrological data, especially river flow, dam or reservoir data, and so on. It's often treated as national secret. And as you know, water is also a reason of conflict in many areas. So the data that is not coming from the ones that are coming from the remote sensing from the satellite, of course, this is open to everyone. However, when it comes for data that is collected on the point, the government often owns them, and it's up to them if they want to share it or not. So this is where WMO steps in and makes sure or encourages the government to share the data, collect the data in the right format, and also share it at least a minimum set of data. As in, for example, in the temperature data has to be shared, the water level data has to be shared for specific location. So confidential locations are of course identified and agreed on, that these are some areas that which is okay to not share, but all the other areas which are crucial for the models, which are crucial for your neighbors to make calculations and so on, this has to be shared. But they are shared among themselves. So these protocols are also set up. So if let's say in this area, I'm just giving giving an example, there are country for A, B, C, and A and B would like to share with themselves, but not share with C or not share with D, for example. Those protocols are also set up. Depending on the political sensitivities, we also negotiate on that, and we set up systems where data sharing is happening in the region, but is not open to others. If others would like to have it, they would have to request or ask for permission, and with the right kind of explanation, they could have access and so on. But if people would like to have access to data, this is often open source, and they could. You just need to let us know what kind of data you would like to have. We have the WHO's WMO Hydrological Observing System. It's a website. You have all the information there. You have information on all the metadata that is available. So when you go to a point, you see what data is available, not the data itself. But you see, okay, here we have the water level, or the temperature, or the pressure, or whatever information at that point you have, and for what time length you have the information, and you can request the information there too, and you get it directly from the country.
Thank you so much.
Okay, with that, thank you so much, Dr. Mishra, for sharing your scientific perspectives and guidance. Now, we will now open the floor for, the questions are done with. We now move on to the second segment of the session. Dr. Mishra, would you like to continue? Yes, thank you.
So we'll go a little bit about what we do. So we have now identified the problems, and now how we are trying to solve them hands-on. So we know that the water climate nexus is complex. We know that the heat is generating more intense rainfalls and droughts after a certain height. We see at the higher levels, we don't see reliable information when it comes to the source of water, or we see minimal ice reserves now because of the heating temperature, and our precipitation future is also unpredictable. Therefore, again, it makes more sense than ever before that we need better information to be able to handle this kind of situation, to adapt. To mitigate, of course, comes a bit later, but first to adapt and live in these situations, and then to mitigate to make the situation better. The problem is also declining networks. So the amount of networks that was there in the past is now declining. It's also coming from the reason that there are other priorities of the government. Now you see there are so many floods that are, so many wars that are happening. So more money going into security and many other issues. So we see that surface observation, hydrometry networks, these are often declining, meaning we are getting less and less data with time. However, water data, climate data, these are all critical information, not just for infrastructure planning or climate analysis or wash sector or food and agriculture, but really for everything, for trade, for tourism, for digital economy, for transportation. For example, the flood that we had in Dubai last year, it caused billions of dollars of loss. Just a 3 days floods. This was a flood that happened because of coastal heating, and Dubai saw rainfall that they had never seen before for 3 days, and flights, 500 something flights were cancelled. So people did not die, but when it comes to economic losses, it was massive. So we need good prediction. We need good lead time to react for everything, including economy. And this is where WMO comes in. Our core business when it comes to hydrology is that high quality data is supporting science. All the information or the decisions that we are taking or helping the countries to take is based on science, on latest data, and not let's just do something. It is absolutely based on the thorough knowledge of what is happening. We'll give you some examples of the status of monitoring, for example. This is for Central Asia. So you know that Central Asia has very high mountains. That almost 90% of their summer water supply, it actually comes from glacier melt, snow and ice melt, and however, when it comes to monitoring station, when you go beyond 3,000 meters, so the elevation here is in meters in the y-axis. When you go beyond 3,000 meters, in total, you have 7 stations. In total of Central Asia, you have 7 stations. What does this mean? It means extreme, huge gaps in knowledge. We do not have enough information to make the right kind of prediction. So the number of stations or the network of, or how dense the network is, also tells us a lot on what is really available and what we could do with it. So what WMO does in this kind of situation is bring in collaboration. So we create regional centers, and we make these countries work together, share data. Even if Central Asia, for example, has less, the rest of the Asia then shares data with Central Asia to make sure they are also able to make good predictions. Another example here is, this is from the project that I lead, which is called the State of the Global Water Resources Report. We have been producing it since 2021. So when I joined, this was one of my first projects that I started. This is giving, you must have always seen the climate stripes that I showed you, the temperature stripes. We have similar stripes for greenhouse gases, for CO2 emissions, for temperature and precipitation. You also have stripes and graphs. But when it comes to what happens really after the precipitation has fallen on the ground, it comes to hydrology. So this report gives you an overall idea of how much water is available in the rivers across the world, and also how much of was it normal, was it let's say we are talking about the Ganges. So what do you see in the Ganges in 2024? Was it normal for Ganga, or was it really above normal or below normal? So what we do is take this big information, again, as the question that Saikat said, we are also users of this data that the countries are sharing. So we take data from these data centers, we analyze them, and we provide information in a way that is easily digestible, because our audience, of course, we have a lot of scientists working with us, but our audience are politicians, media, people, general public who are not scientists. So we take all this data and we make it into a format that is easily understandable. So we color code them. I'll show you some examples of what we do. So these are all the variables that we cover in the report. So we look into, when we started the report, this was 4 years back, we started with only river discharge, and river discharge meaning how much water is available in the river, how much flow is happening in the river. We started with that, and we started with total terrestrial water storage, which is a combination of everything that is available on the ground. This was a remote sensing based analysis, and we had an overview of how many disasters happened in the year when it comes to floods and droughts or high precipitation events. However, now in the last 4 years, we have added all these variables, and we take data from all kinds of sources. In the first slide, I said we use innovative methods. So what we do is we use models, we use remote sensing data from Earth surface models, we use in situ data. In situ is observation data that the countries share, and then we can make all these calculations. And every year we are trying to also add more variables. The ones in red, lakes, water quality, and precipitation, these are the variables that were added this year. And what we do is take all these time series information of the years of data that we have, and we change them into percentiles, and we show them only in color. So I'll give you an example here. So when something is in the normal range, so we compare the data with 30 years of data of that particular area. So we compare Ganga with Ganga, for example. So we take the data from Ganga, we compare it with 30 years of data of Ganga, and we say, okay, was this normal or was this not normal for Ganga? And we do that for all river basins around the world. We have divided the globe into around 1,300 river basins, and then we do this for every basin. This is for the river discharge. We do similar calculations for groundwater, for soil moisture, for evapotranspiration, for precipitation, for all variables that we could think of when it comes to the water cycle. We take all kinds of data, and of course, not always we have 30 years of information. It's a lot of information in this slide. I will not like you to go through the details, but just to give you an idea that for different variables, we have different kind of lengths of data. For some, you can see we only have 19. For some, we only have 15. But ideally, we would like to have 40 or 30 for most of the variables. Now, what we saw in 2024 was you see this pixelated data. So this is point data, combination of point data of how much precipitation did the globe receive in the last year. And as you can see here, in many areas, they were much above normal. So meaning these were areas that received more water than usual. However, you see also areas that were orange, dark orange, and so on. So what it helps us in doing is calculating how much, when we compare it with the discharge, how much did the precipitation change to discharge, or did it go somewhere else? So water also manifests in other forms. So some is stored, some is going to the groundwater. So we'd see an increase in the groundwater level. So when we have access to this kind of global data, what it helps us to do is to analyze which are the hotspots, which areas did get more affected over this year, and which are the areas that are seeing impact of which one is a signal of precipitation, direct signal of precipitation, or which one are the areas that are actually affected by long-term climate change. So the slide, this one before, it's a combination of complete and incomplete data. And what we do with incomplete data is try to infill this. So when we have 30 years of data, for example, but 10 or 5 years of data is missing, often this data is then thrown out and we say, oh, this is not usable. So what we do here is use remote sensing data, satellite data to infill these gaps, and then give it back to the countries and say, okay, here is your data, you can use it for whatever you want. So these are some of the examples of activities that we do and make data more useful for the countries. But this can only happen when there is openness to share data. And then when we try to bring this from global to state level, then global to regional, global to national, and then national to state, this then holds true for the states as well. There has to be a sharing of information across borders within the country, and then sharing of information beyond the country so that this can then be useful. Now, these are information from global models, because in the previous one, you saw there were a lot of gaps. So what do we do when there is gaps? We don't get a full picture. So we use a lot of global models. And again, this is where this is where we also use a lot of information coming from the public. We use citizen science. We get information. We try to get information from the public, as in how they felt their basins were, if that corresponds to what we saw on the report. So what we see in the global models, if it actually corresponded to what the public saw on ground. So if they thought their area was actually much drier, but we see in the models that it was not. So this is where then the public perspective then holds true, because they have the right information, and what we're doing is model simulated. So we try to improve the model. So this then helps the global modelers also to make better models. Because of these kind of global models, we're also able to have water stripes. So we see that, for example, this is the stripe from 2023. We saw that 2023 was the driest year ever. So what this means is more than 70% or roughly 70% of the globe was under not normal conditions, and 45% of the globe was actually dry. So imagine almost 50% of the globe was much drier than normal, 50%. And that's huge. And this also means less water availability, less water in the reservoirs, which then triggered the governments to start saving more water, to prepare and use the reservoirs accordingly. And this report, for example, was also used recently in G20 discussion that happened in South Africa last month. This report was also used to make decisions on reservoirs and planning what kind of investment should go into water. So the citizens are involved, the member states are involved. This is a classic example of local to global. So taking information from all different little pixels and then putting it together to a global picture, and then taking global decisions on investments based on this global picture. Similarly, we have examples from reservoirs, from lake storage, from temperature, lake temperature, and this is a combination. This figure here shows a combination of everything that you see on ground. So here you see there are parts of India, for example, that are extremely wet, but others are dry, and there are some parts which are normal. The normal ones are not the ones we are worried about. We are worried about the greener and the orangish pixels. And what we saw, we started with 7 countries when we did start. And because of the value, this is another example from what Paulomi asked me before. Can a small
Okay, just right now.
Okay, this is also an example of the question that Paulomi asked before on can little changes have a big impact. So this is also one of those examples. We started with 7 countries in 2021, and now you see we have 60 countries on board which are actively sharing data. Back in 2021, it was only 7. But why did this change? Because we start with a little project, we show the impact of the project, and when the countries see what can be produced when the data is being shared, they are more open to sharing their national secrets than keeping it to themselves. In this world of AI and remote sensing, of course, no data is really a secret anymore. If countries are not sharing the data, we will anyways fetch out the data from the satellites. So it's smarter that everybody is open and everybody is sharing data, and this then goes down to the local scale as well. And all of this is not possible. It's not something that I did it myself in the secretariat, but it is really with a combination of many people. And why I show this picture is because there are many students behind these projects, and behind each of these logos there are master students, there are PhD students, there are bachelor students who have worked on creating these models and running these models that are then supplied to WMO to create these projects, which make it then to the global decision-making stage. Often when PhDs or be a bachelor's or master's students, they're working in their own labs, they produce their own paper. However, when they collaborate in the larger scale to projects like this, the voice is much more amplified and it has much more impact. So this is again going back to emphasize that whatever project you are doing, make sure that you are trying to push it and make it visible, and look into national projects, regional projects, projects of the government, where you can actually make a case study and make sure that other people are also learning from your experience. If you have a positive experience in something you did that worked well, for example, the thing that you do with water management in your schools, or saving of electricity, or saving of water, if you can make a little maths out of it, if you can make a case study of I did this and this is how much water, not just in terms of bill was saved, but in terms of water bill or electricity bill was saved, but in a larger picture, this is the amount of water I actually saved, and this is the impact. So if you can make a small vlog out of it, these days it's really the time of Instagram and YouTube and all of this. If you can, we see all kinds of unnecessary videos that are going around. But if you can really make some useful information out of this and create an impact on other students to repeat this, or depending on which level you are, if you can do some projects that can be shown in the national stage or in the state stage, this can then create a ripple effect. I will give you another example of decision making using projects or information that are coming from ground, and then a lot of students again involved in the stage where we have hydro models. So we take ground-based information, remote sensing information, climate forecasts, but then we use hydrological models which are developed by students in the universities, in the colleges, and then we create web-based products where all this information can be disseminated. So what you see in the water report is an annual snapshot. How did 2024 look? But this is not useful when we look back. If you want to say, okay, today I want to make a decision today for next year. So the water report is not going to help you there. The water report can help you make decisions on hotspots, on where the big investments can be made. But if you want to make decisions, should I open the dam or not? Should I let more ships come into my stream or not? These kind of decisions, for this kind of decisions, you need planning you need an idea of what your reserve, what your water cycle looks today, what your area looks today, and how it's going to look in the next 3 to 6 months. So accordingly, you can make the planning for the water resources, because you need to give directives. The water dam operators need to know, the water supply people need to know, the tank operators need to know, and they all work way in advance. So for this, we use a lot of models to make the predictions. And this is again something where students are heavily involved. Of course, we do a lot of validation with the data. We have the best scientists also working on it, but behind this is a huge force and these models are very heavily dependent on the student force, mainly PhD students in this case. And we take all these existing products, the local, global, regional products, and we make it into a standardized operational products. And and what it gives is a current overview of how is my river flow now, how is the soil moisture now, how is my groundwater now, and how this is going to change in the next weeks, months, up to 6 months. So we look into seasonal, sub-seasonal prediction. And currently, this also started in 2021. And currently, we are in 60 plus countries. In the different colors show how they're being operated. In 60 plus countries, we are setting up the hydro-SOS. This is the hydrological status and outlook system. So what the portal gives you is with little dots. This is an operational system. So you saw the water report, which is the snapshot, and then we have the hydro-SOS, which is updating every 15 days, every 7 days, and it gives you a real-time forecast and a real-time status and a forecast of the next weeks and months. And what we also do along with generating this is not something that we generate in the Secretariat, because we really want the countries to do it themselves. So we also do a lot of capacity building programs. This is a recent example from Nairobi, where we had 5 countries from the Nile Basin, and we capacitated them to calculate the status products along Nile in a standardized format. And you see some dots here along the Nile as well. So it was Sudan, South Sudan, Ethiopia, Uganda, and Rwanda. These were the 5 countries that were involved, and we have several projects similarly to this one in Lake Chad, because I have the African map here. So we have another project similar in Greater Horn of Africa, in Lake Chad. We have in Lake Victoria Basin, and so on. So we do a lot of capacity building to make sure that these good products that we are talking of, and we see there is a lot of value, the countries are able to also do it at their local scale, and then send us the information. What we also do is reporting. This is an example of a masterclass we did. What we did was we in the beginning of the year, we realized there's a lot of misinformation about glaciers floating around. So we did a masterclass for journalists. So we did a capacity building for the journalists, hoping that then the information they share is absolutely based on the science that we tell them. We were really hoping maybe we will have around 50 people who will join from countries which have glaciers, but we actually had 360 plus journalists who registered, and we had the journalists. We did a pre-survey asking them, how much do you really know about glaciers and cryosphere? And 70-ish journalists said that they don't know anything about glaciers. And at the end, we had a 120-minute session, so it was a 2-hour session of a masterclass. We gave 40 minutes lecture, and then we open the floor for questions. And yeah, 82 questions just showed that there was a lot of interest. Many journalists from India, for example, also from Africa. Africa just has 1 glacier left in Kilimanjaro, but even then there was a lot of interest from Africa, just to show that people like to know. So if you share information, if you share your knowledge, there will always be people who would like to know about this and like to, if it's big enough, they would also like to report about this. And this is something that we consider as a big success, because we are often talking as scientists, we are often talking to scientists. So we are talking to converted, but not really to the people who are sending out the messages, who are journalists. So one lesson that we learned from this exercise was it's very, very important to tell the story to the right people in the right format that they understand and they absorb it. So this is also a message that I would like to give to the students, that if you have some project, if you have some message, record it in a way, or not just through videos, or also through blogs or vlogs, and make sure that this is being disseminated, the information is being disseminated, and only then it can be amplified. And the added values of these kind of science-based products that we do, it helps us summarize everything. It gives an authoritative voice and it gives a unbiased opinion of the entire globe. And it helps us in identifying where should the investment go, how should we make the comparisons, how we can inform these large processes. And this is exactly what it is doing. And when this is done at a lower scale as well, a lower as in a much smaller scale, at a national, at the regional scale, this will have even a bigger impact. The final takeaway is we need institutional collaboration. There's a very crucial role for monitoring, for data management, and also including citizen science. So this is also something where students can be involved in citizen science. In Africa, for example, we have this network called TAMO, TAHMO. What TAMO does is very smart. They put monitoring stations inside schools, and they make the students the custodians of the data. So this is done because in Africa there is a lot of problem of vandalism. The stations are put with the batteries and satellites, connection to the satellite, etc. However, in a few days, the equipment is gone, the battery is gone, it's stolen or broken, or somebody takes it away, and so on. So what they have done is put stations inside schools, and the school students are then responsible to make sure that the data is being collected and is being logged. There is a simple app where they can log the data, and then these are the stations where we have the maximum or the longest data, because the students are also very proud to be a part of the bigger picture, or they know that they're helping their government to make the predictions. They know that they're helping make their community a bit safer than it was before. So these are examples of citizen science. Also, there are so many projects where you can take a picture and upload the picture. It's usually used in floods and droughts. So you can take a picture of the water level, and you can upload it, geotagging it, giving the longitude and latitude. So the people who are responsible to make the analysis, they also know in which area, which level of flooding is happening at the moment, because the government can only know a certain points, because that's where they have the stations. But if people start taking pictures of along the way, it makes the life of the government, or of the people who are sitting there to make the calculations much easier. And the next one is to leverage modern tools and to generate AI and other kind of like Earth observations, etc. And of course, the last message I would like to leave you with is that we need the next generation of diplomats, next generation of researchers and experts who are working on topics like this, which makes life a little bit safer for everyone around the world. And if you look at the science practice policy, WMO sits exactly in the middle. We do the science, we help in the policy making, and then we convert and we help member states convert this to practice based on the science. And I would like you to think and ask yourself where you see yourself in this science policy practice nexus, and where you see yourself now. I think for now you probably see yourself in the science part, trying to, you're still learning, but eventually when you go ahead in your careers, where you would like to see yourself, and how you would like to cooperate and provide further inputs and grow in this part. And this is a picture borrowed from my journalist friend from Circle of Blue. It's a picture from Afghanistan, and it asks us if we are a generation that lost everything or we did find some solutions. With that, I finish my talk. We still have around 11 minutes for questions.
Participants can unmute themselves now.
Yes.
All participants are requested to please pose their questions in the chat box.
And you can unmute and ask also directly, but please be careful. Let's not lose time here. Ask maximum questions. Hello, audience, please ask. Do we have any questions in chat? Cycle?
Not yet, ma'am. While the other audience can quickly type the question in, ma'am, I'd like to pick your mind a little bit. In your work with the cryosphere and hydrology department, what is one finding or trend that you feel that the next generation must absolutely know? Something that could redefine how we live in the upcoming 20 or 30 years.
By trend, you mean trend in the data or what?
Trend in the data, trend in new findings that you have seen, or something that is like you've noticed something is happening, and this, if not,
Yeah, what we notice is it's difficult to predict which area is going to be a bit more safer than the other. It's getting more and more erratic. The areas that used to get a lot of rainfall and used to be very wet is not wet anymore. It's changing over the years. So what we have found out, of course, this is maybe more philosophical, but we need to be more agile and open to change. And to moving and to changing profession as well, as in to keep upgrading yourself every couple of years because the technology is changing so fast. I think this is also not just for hydrology or climate and so on, but this is really for everything. What we see is our dads, for example, could have one profession for their entire lives, but this is not the case anymore. In whichever profession you are, we see this even, for example, in our case, for if we did a flash flood guidance system a couple of years back using a certain model, that model is not good anymore. And because with the new data, with the new technologies that are coming up, you need to upgrade yourself every couple of years. This is on the technology side, and from the water quality or water availability perspective, you need to be open to moving and open to new changes. We know, for example, what the Dutch have done. The people in the Netherlands, Dutch is one country which is way below the sea level. So what they do is every few months, they keep adapting, they keep building canals inside the city and draining the water out. And this is the only way that the entire Dutch is now still standing, or it's not drowned yet. So we need to find solutions like this, which are out of the box, and be open to move.
Do you think, ma'am, that AI has a big influence in the upcoming changes that are coming up for our world?
Sorry, DI, what is?
I'm saying that, do you feel AI will be having a big influence
AI?
in the way we
AI,
are?
of course, we are using, so for the forecasting part, absolutely. Machine learning AI is being used a lot. We have a project going on with Microsoft and with Google. We are now starting to use AI for flood forecasting in many cases, especially in areas where we don't have enough data. And in these areas with remote sensing, what we are trying to do is see how many pixels of area used to be flooded with this much rainfall. And if we have X amount of rainfall, how much could be flooded? And this is being heavily done with AI. And it's because AI is also much faster. When it comes to both climate and hydro modeling, AI does things 10x times faster than physical process-based models, and we are getting more or less the same results. We just had a paper published in the Nature by Greg Nearing from Google, who exactly proved this, that when in the areas where there are less amount of data, AI is actually proving to be much better than process-based models. So we are going to use AI a lot. We have already started, but it's only going to go more. Of course, we can't leave the hand of process-based model because that will explain us why we are seeing what we're seeing. But AI will help us predict things better.
Thank you, ma'am, so much. There's a question from a student, Ayushman. What kind of data should be collected for proper water management in schools?
At schools, yeah, when we it's yeah, the size of the unit wise, this is quite small, but what we need for sure for better management is the effective usage by the people. So you can make a very rough calculation of how many students are there, how much water do we really need, let's say 1.5 liters or so for drinking, and let's say another 4 or 5 liters for sanitation during the whole day. So X amount of students plus this much into this much water is how much we need, and how much actually are we spending. So this could help us to do a water balance or a water accounting. Let's say this is usually the first step to start. And how much are we actually generating? So are we generating enough? If we put some meters, we can also find out how much are we actually generating and sending it back to the aquifer or sending it back to the river stream. So what is our net balance of water of our school? So this is something we do what carbon accounting. If we start doing water accounting, I think we'll have a much better approach towards water if we realize how much we are wasting or how much we are using. That could be a starting point.
Okay, I think
Any
there's
other
time
questions?
I'm just going to conclude now with this question because there's very less time and ma'am has to go. So this question I've been basically framing to ask you. Now that schools are participating today, they heard you out and there are questions. I'm sure they've got a number of questions to ask. Now, what is happening is schools do not have any direction as far as climate work is concerned or environmental. Every school is doing something or the other, and then they are doing humongous amount of work, but there is no, what should I say, no body to actually monitor that and see to it, it comes to a place where actually that is contributing in a significant way or making difference at the end. So I was just having this question here. What guidelines can WMO offer to schools to help them plan and implement structured activities that address and mitigate climate concerns? So,
yeah, very good question, actually, Sangeeta. After I heard the questions of Paulomi and others, I was also thinking about the same. How can we really make sure that this is heard at the highest level? But maybe we should tackle it in a way that we start with documentation. We start with what the schools are doing and what they think are the impact. We have, of course, projects of innovation like it's similar to what we have in countries. For example, countries often we have national exhibitions where you go and show your models, right? And then you get a prize, or then the government decides, okay, this is good enough, this prototype is good enough, let's scale it up. So these are the projects that we also have for at a bigger scale. We make it open to the global audience. It's called Hydro Hub. What it does is asks for innovative methods, so people could students, citizens, they can, or scientists, they can put in their ideas of what innovations could be brought in when it comes to monitoring or when it comes to improving a certain system and so on. The project is called Hydro Hub. It's going on for 8 years now, and every year we fund certain number of projects that they can then scale up and be used in operational. But this is again a drop in the ocean, right? Because there are so many schools only just in your area probably which are doing so many things, and these kind of initiatives of course gives a voice or to a selected few, but not to all. But we would really like to have, the idea would be to have all of these voices heard. So if just thinking out loud, and let's think together, what I would recommend is we can start with documenting every little change that you're doing, or what impact it is having, the change and the impact. And if we can document and make this available for the others to read, and we need to really sorry, and we really need to start from bottom up approach on this. If you can bring all this information together, you told me that Kerala schools itself, it has around 300 schools, was that right?
No, they have got about 8 schools, but Kerala Public Schools has floated a program from the month of
Okay.
July to December,
Okay,
wherein 70 schools have registered, 70 plus schools have registered.
So the starting point could be this, right? So 70 schools getting this kind of a standardized document. So what you can do is create a template of what change was done, what was the impact, what was the objective, was the objective achieved or not, and how many people participated, just to show if there was enough interest or not in the students and what can be changed. And if only for the 70 students, you can put this together and then publish it. There are so many public platforms where this can be published, or make a news article with it, and then make this once this is done and this is heard, then we can float it. Then we can start floating it up.
Okay, so what I was thinking, like in the month of December, the schools will be submitting, the entire compilation will be done. And then they will be felicitated in the month of February, awarded and all that. So after that,
awarded on the basis of what?
Awarded on the basis of the activities that they have done, the impact and the sustainability, and the kinds of collaborations that. So these are the 4 parameters. And once that is done, we will select the certain number of schools who have done exemplary work, whose impact has been there, and who are planning to carry forward that activity. So those particular reports, what I'm trying to say is, how can we engage with WMO to take it further in a place so that more schools are attracted to this kind of work? And as you said, by 2027, everyone should have early warning systems. I think that is a big alarm. It should not just remain activities limited to schools. I feel the reach has to be further. It has to reach many people, not just local communities, but practically the globe. So if we could connect with WMO and we can pass on these reports to you so that you put it on your website or somewhere saying that the schools are making this effort, then how can we take the collaboration further? That is my
Sure. What we could do is, after you have this final report, we will have a closing session of the International Year of Glacier Preservation. In the beginning of the session, you did a program where you floated the idea of this is going to be happening and so on. Yeah. And it will be nice in the closing session. This will be in March 2026. So in March, if you can have an event there and speak very openly about the lessons learned, and also the things that worked and the things that did not work, for example. And of course, together we could do a news piece on this.
Wonderful. I think that is going to give us a good leverage so that we have more schools on board and there is a direction, and that direction must lead to the purpose that we are trying to address right now.
Absolutely.
And, yeah. So I think your inputs have kind of triggered a lot of thought processes right now. And I'm sure all the audience's heads are buzzing with ideas and how to take things forward. So thank you once again for the active engagement from the audience. This has been...
Sangeeta, if I may ask, how many students, because I can't see the number of students that joined, how many students were there in overall, roughly how many students were there, and what level were they in? Were there high school students, college students, or what level are they in? 11,
Basically,
12?
we asked a grade 9 and above to join because they will understand this. And every school perhaps had a certain number of students joining. Since it's a working day, they have got classes and exams just from coming week. So we've asked maximum number of students to join depending on their
So it was 9 up. Okay.
Yes.
Okay.
So
Thank you.
Yeah, I'll just give the closing address. Just a moment, be with us. As we come to the close of this plenary, I would like to take a moment to express our heartfelt gratitude. Profuse thanks, Dr. Mishra, for generously sharing your expertise and precious time with us today. You have given our audience a deeper understanding of the various aspects the schools are pursuing under this program, providing astute guidance on how to interpret and apply this knowledge effectively. A special note of thanks to the dignitaries, respected teachers, and curious students who joined us today to be a part of this global learning space. We are grateful to Mr. Gaurav Singh, Mr. Murli, and Mr. Saikat Raut, whose expertise and behind-the-scenes support have greatly contributed to the success of this session. We hope that the insights and discussions from today's session will inspire continued learning and collaboration. Your interaction and engagement with our students with today added depth and significance to the session. With that, we formally close today's plenary. Thank you, everyone. Wishing you an inspiring and fulfilling day ahead. Thank you so much.
Thank you.
Thank you so much.
Ma'am, I'd like to draw your attention to a comment given by Madam Shubha over here. They said there were 20 in number from classes 9 to 12 altogether attended in a classroom. The number of students.
The recording will be shared with the schools, so they will all have access to this. And that is how we are actually ensuring that they hear you and learn from you. And one more request, if it is possible, sorry. Will it be possible for you to share your presentation so that our schools can refer to it and just keep it as, yes? Oh, that will be wonderful. Thank you so much.
I will share it with you.
Thank you so much. Thank you so much.
You.
Thank you.